Hi, welcome to this recording. This is for my Astronomy 1 class. I'm doing an overview and really walkthrough for the third lab for Astronomy 1, which covers stars and constellations. And it's mainly for students that are either stuck in some part of the lab or they cannot run the full version of Stellarium on their home computer, and they're using this video to complete the assignment. So with this lab, again, with completing lab reports, you'll be asked to include an introduction, which is a summary of the purpose. So I generally have that within lab instructions, but you want to take that and put it in your own words, put it into about a paragraph length. Have a paragraph or two summarizing the procedure of the lab, basically kind of describe what steps you took to complete the lab exercise and answer the questions. And then with that, you'll have a data or discussion section, which for many labs, you'll just be answering lab questions. Some labs you do have measurements to do or tables to complete. You would include that in that portion of the lab report. And then finally, you would have a final paragraph, which is your conclusion, which you state, do you think you met the lab's objective? Did you learn anything interesting about the lab assignment? Do you have any difficulties? Can you think of any sources of error that might affect your measurements or results? That's things you would put in your conclusion. So I know the bulk of it is answering questions and doing calculations, but make sure you include those other three parts. So here, this last purpose is to get you familiar with stars and constellations that are visible from our part of the world, kind of mid-latitudes, continental United States. You'll be also introduced to the concepts of asterisms and modern constellations. So hopefully you've read the course material covering this section and see my PowerPoint slides where I do go a little bit to star names and different constellation types. Constellations in the ancient Greek times were recognizable star patterns, but over history, as more and more stars were able to be seen from the 1600s with the discovery of the telescope, they had to be plotted out. And eventually, constellations became more than that. And in the modern sense, it's really not just the brightest stars, but actually areas of sky. And I can kind of show that here. See constellation boundaries. So, like right here, there's a title out there. Okay, here's Scorpio with the stick figure there. So in ancient times, Scorpius would have just been these stars that are connected by the blue line. But in a modern sense, anything within that red area is now considered part of the modern constellation. So this allows us to kind of map stars that might be too faint to see without a telescope. If I zoom in and just kind of scroll around, you can see there's actually more stars you can see. And anything like really 6 magnitude and beyond would be something you need a telescope to actually observe. The information given up here. So that allows us to organize stars effectively. And then other bright star combinations might be part of a constellation or cover multiple constellations. Those now termed asterisms. And if we look to the north here, I'm just scrolling around. One common asterism is the Little Dipper. So we'll put asterism lines and names. So this whole thing here, even though it's part of the original constellation, this is considered an asterism. We also have the Big Dipper here. That's part of the larger constellation, the Great Bear or Ursa Major. So we're going to learn quite a bit about those things within this lab exercise. And these constellation areas, they number today 88, and they do cover the entire night sky. And some of them are named connected to the original constellations, kind of put together by the ancient Greeks and within Ptolemy's alchemists. But there were other areas in the southern hemisphere or small gaps where there weren't really any bright stars that kind of more modern constellations were put there. So you might see things named after instruments such as the telescope or the microscope or the compass. They'll be, of course, in their Latin name version, telescopium. But they all were kind of added in to make sure we filled in the entire sky for navigation and astronomical purposes. So let's see here. I want to adjust a few things. I got too much information here. There we go. Okay, so let's start off, and if I need to scroll a little bit, I'll make this a little bigger. So let's turn these off. So let's see, constellations. So for the first section of the assignment, we're going to look at some differences between classical and modern constellations using Stellarium. So I've already done kind of the first portion here, started Stellarium. Usually kind of there's an icon on your screen, start it up. We're going to go to the information tab, and I've already kind of went into that. So if you go to configuration, doing this on your own, configuration is always the one that has like a wrench and a star. There's different tabs here, different tools and scripts. Hopefully you have the plugin angular measurement checked off. You probably did that for lab 2. We want to keep that. But with that, we're going to go in and click on information, and we're going to control what we see. So in there, we don't really need a lot of this stuff right now. Actually, we don't even need coordinates. We're just going to worry about the name and constellation. So right here. So I click on a star, it gives me its name, and then it gives me its constellation short letters. So DRA is actually dragon. So now next thing we can do is manipulate time. So I'm gonna have to expand this out here to get all my time controls. So we want to set the time to midnight and also be within the city of Richmond. So let's go in here. Okay, I type in Richmond, of course, it gives me a list here. Go to Richmond, Virginia. Moves my icon here to the correct latitude and longitude. And fix my time. So again, right now it's running 1 second per second. I'm going to stop that. Sorry, right here. And then adjust my time. Go over time window or hit F5. And then I can adjust the time. So we don't really need to worry too much about the actual dates. We just need the time corrected. If you do have meteor showers, they're fine, but you're not going to be studying them, so you can turn them off. So it's highlighted, means on. Click it, it's off. Get rid of some satellites too. Okay, next thing, open the bottom toolbar and toggle the constellation lines and constellation labels. So hopefully from lab 2, you kind of activated these. so you see all of them. If they might be the default with the most current version. So labels and lines. So kind of the familiar stick figures. Okay. All right. You can see quite a bit here. So Draco the dragon. Yrzer's the big bear. The little bear. Yrzer's minor. Again, most of these constellation names are either Latin or Greek. You see Cepheus, Cassiopeia are Greek names dating back to one Greek mythology connected to, let's see, the Kraken and Perseus. I believe they were the parents of Andromeda. Monosaurus, or unicorn here. Canis Major, big dog. So you can see constellations have a variety of kind of individuals, objects, and animals they're named after. Leopardus is just means giraffe. Long neck here. Put some artwork there. It's going to show that I am not trying to trick you. That does mean giraffe. Okay, so that is that portion there. Now we're going to get rid of this horizon here because we want to be able to look at all the constellations. So I'm going to go into another option here, sky viewing windows. Let's turn off that ground, turn off the fog, and voila. I don't want that. Here we go. Now I can zoom out and actually see everything. Look anywhere around. Actually do this. Of course, you'll see our sun there. You also see faintly the Milky Way band as well. There we go. Well, the thickest part is down here. So there, that gets to that part. Okay, so we can now see all these constellations. But now let's take a look at them in terms of their modern version. Get rid of lines and labels. I'm sorry, not labels, put up boundaries. Okay, so I can look directly south. And I can see how each of these are kind of marked up into different zones. Some are large, some are small. So they are not regularly organized across the night sky. They are, again, kind of organized based on kind of their historical position and around kind of some of the brightest objects, at least in our skies. Let's it does allow me to zoom in and out, looking at things. So questions 1, 2, and 3 here. Let's name 3 of the smallest constellations, 3 of the largest, and then select a constellation using the angular measure tool and find that angular length of course, its largest size or side, the nearest degree of your selected constellation. All right, so let's look around here. Okay, Canis Minor is actually pretty small. Paraxis, which I believe is the compass or astrolabe. This one right here, this huge ship, used to be one full constellation named after the Argo. But since that, they've kind of broken it up into different pieces of the ship. So Vela is the sails. Pupus is the bow of the ship. Carina, kind of the back stern. Volans here is, I believe, a fish. Let's see here. So some of the smaller ones are kind of ones you probably never heard of before. Let's see. You don't have to be exact. You just want to try to get something that is relatively small. So in that case, Musica, the fly here is small. The Cross constellation, sometimes called the Southern Cross, that's really small as well. It's beneath the Centaur. Corvus, the Raven, is small. Triangulum, again, as you can see here, many of these are modern or more modern scientific instruments. Aquilus, which I think is a horse head here. So those are a couple different, fairly small. So if you need to stop the video, you can do that and you'll be able to see those names. So some of those three smallest ones, Sagitta, the arrow, it's another one. Put them under question 1. All right, so let's now look for some large constellations. Okay, so some large ones, Cygnus. Cygnus is pretty large. That's kind of known as the Northern Cross. Draco is pretty big. It's long and stretchy, so this entire area here. Ursa Major is fairly huge. Again, pretty big there. Let's see. Then we have this flowing, in terms of lengthwise, Eridanus, which means river, flows all the way around up here. It's a pretty large area. The longest in terms of length would be the Hydra, kind of the water snake here. So that goes across. So I'm going to try to make a measurement of that for 3. So to make measurements, you're going to go hit your angle measurement tool and then tap on one end and move it to the other. But I need to, oops, let's try moving this a little bit so I get the entire length. Maybe not. Here, I'm going to do this. There you go. So let's go from this corner to this corner here. Or actually, let's try it the other way around here. Fortunately, the numbers are at where you start. So to the nearest degree, it's 104 degrees, stretching across the Hydra. So in terms of nearest degree, since there are only 60 arc minutes in a degree, the number that's the boundary is not 5, but 30. So 30 or more arc seconds, it goes up the next degree. If it's less than 30 arc minutes, it goes down, you round down. So that's one example. Let's see if I can measure. Let's do a comparison. Let's do Draco. It's a fairly big constellation. Give someone an option. So going from here to the top of this beak. All right, so Draco, as you see, is much smaller. It's only, let's see, 55 degrees and 57 arc minutes. So we'll round up. So that's going to be 56 degrees for Draco. All right, so that we have for questions 1, 2, and 3. All right, now for question step 7, from the bottom toolbar, toggle constellation art. I already have it up. And use your arrow keys or mouse to scroll around. So I'm using left click to just move around here. But if you don't have a mouse, you're just using a laptop, there are other keys here listed that allow you to kind of move around. And adjust things. But I find it's a lot easier if you do have a mouse. Okay. All right, so right here, select the constellation you are unfamiliar with. What is the illustration for that constellation? Okay, so let's see. Anyone here a Centaurus? Okay, what does the Centaur? Alpha Centauri is part of that. It's got another different name here. It's also got Rigel Centaurus is its kind of proper name, but its Bayer system name is Alpha Centauri. Let's see. Just screwed around. Cancer is not a disease here, but is the name for a crab. We have Orion the Hunter. Cetus the sea whale or sea serpent. We have Pegasus. You have Hercules, Orphicuchus, which is the serpent bearer, kind of a healer for the ancient Greeks. Let's see, Vulpecula, Latin for fox. Do you have a chameleon? And then octants, which is a type of instrument for measuring angular measurements. We talked about, if you did the readings in the slides, we had angular measurement tools such as backstaffs or sextants. Octants is another example. It's 1/8 of a full circle, I believe. Okay, so asterisms. Let's see. So some well-known star patterns are not classical constellations, but as I mentioned before, but there's some subset of a single constellation or grouping of bright stars across multiple constellations. A couple examples include the Big Dipper and the Summer Triangle. These groups of bright stars are called asterisms. So we're not going to shift our location and time because we're going to look at some summer constellations and asterisms. So okay, so we shifted a little bit north and then a little bit to the east. And we're going to change our date to the June 1st. Next, we're going to restore horizon from the scale from the landscape tab under sky and viewing options. So landscape. Let's show our ground. And finally, we're going to turn on labels, boundaries, and let's see. and turn on the asterisms as well. Okay. So that way you can see the overlap between where some of these asterisms are in reference to their actual constellations. So what constellation is the Big Dipper found in? Okay, so Big Dipper is always, let's see, whoops, Little Dipper, directly north. So that is in the constellation of Ursa Minor. Let's zoom up there. Unfortunately, the lettering is overlapping, so let's see, Ursa Minor. And Little Dipper. So they're both the same thing. So this is an example of an asterism. Kind of looks like a curved pan or pot handle connected to a pot. That is the asterism within Ursa Minor, which means little bear. If we go along, put some of these back on. We have our huge summer triangle. So the summer triangle stretches from Deneb, which is the brightest star in the constellation Cygnus the Swan, goes to Altair in the constellation Koala, which is the eagle, and then up to Vega, which is the brightest star in Lyra, the Greek harp. So those guys together actually cross multiple constellations. So the three that the stars are in, plus they do cut through that Sagittarius, which is the arrow, and the Fox constellations. Okay, so that answers the next couple questions here. Which constellations does the summer triangle cross, and which three stars does the summer triangle make? What three stars make it up? Now, aside from the Little Dipper and Summer Triangle, you're asked to select three more. So there's a couple right here. Okay, Mini Cassiopeia. The Northern Cross is within Deneb. And the Summer Triangle is probably the three brightest stars in the summer. So even if it's a little bit cloudy and you can't really see any other stars, these will be the first stars visible overhead during the summer. The big W here, Cassiopeia. The Longin, which is the dragon head. We have Hercules. Or part of it's called the Keystone. There's a number over here. We have the Great Diamond, which connects four stars here. Spica, Dinenbola, which is in the constellation of Leo. Canis Venonacci, and Arcturus. And I'm going to grab a little more information here. Let's see. Just to pull out the catalog names there. Oh, also Leo, sometimes called the stickle for the head of the line here, or the sail in Corvus. So any of those, you just jot down for the answer for 8. Now, the Big Dipper is among the most recognizable asterism. It's found in the constellation Ursa Major, or the Big Bear. And the Big Dipper is very useful in finding a guide for observers in the Northern Hemisphere. Why? Because those stars that make up the Big Dipper are very bright. They're easily seen. You kind of know which direction is north. You'll be able to see those stars. If you follow the Big Dipper over the course of the night, of course, it's going to appear to rotate counterclockwise around the North Star. So let's go head over to our friend here. Big Dipper here. I'm going to kill some asterisms. Or maybe I just leave that there. But if I would allow time to run, as you can see here, Ursa Major appears to kind of rotate around the center point where we have Polaris, our North Star. And if you have high enough latitude, the Big Dipper will not actually go below the horizon. It'll be go around. We call this a circumpolar. So with that, we're just going to let this go around. Kind of what other asterisms you see here, kind of from Boston, don't go below the horizon. So we're not going to count the tree as horizon. We're going to count the ground here. So like for the most part, the Longin is able to do that. Big Dipper, Ark of the King. Okay, so this kind of section here, these guys are circumpolar for Boston. That means every night, regardless of what the season is, you'll be able to see them up in the night sky. And you might recall a little bit, this is something more talked about in the next lab, but within some of the information on the night sky, my PowerPoints and in the readings, that included information where you're located in the Earth, controls kind of what's circumpolar and what rises and sets. The closer you're to the equator, less and less of the sky is circumpolar, to the point where if you're right on the equator, stars will appear to actually rise directly from the east, go across the sky, and set in the west. So from the equator, you can actually see potentially all the entire night sky, both northern and southern hemisphere, but none of it is circumpolar. Conversely, as you get closer to the North and the South Pole, more and more of the sky becomes circumpolar, but you then see less of the other hemisphere. To the point, if you're at the North Pole, the North Celestial Pole Polaris is directly above you. Everything appears to rotate around that, so nothing rises or sets, but you're unable to see anything that has a negative declination, because that's going to always be below the horizon for someone at the North Pole. And sunsets. Okay, so star names. Many of the brightest stars have names that come from ancient cultures. So if you left click on a bright star, Stellarium will show its name. Let's check this guy here. All right, Algibia. I'm not sure what that means. That is a bright star in the constellation of Leo. Many star names have either Greek, Roman, or Arabic names, depending on when they were given that proper name. Some of the brightest, like Ceres, of course, was given its name back in ancient Greek time. So its word origin is Greek, meaning scorching. It was actually seen above the horizon in the early morning during the hottest days of the year. Conversely, something like Polaris, I believe that is Latin, related to pole star. Also, let's see. Coracoli is another star that's a Latin name. So you can take a look and kind of see a variance of that. So these are they have actually, these are called proper names. But not all stars have them. Only kind of the most brightest stars that were well known to the ancient Greeks, Romans, Arabs, and then medieval Europe. 1603, a German astronomer by the name of Johann Bayer, he thought this was not a very practical way of organizing stars. He wanted to improve upon the previous star charts, so he created, basically created a star atlas called the Uranometria, which means study or measurement of the sky. With metria, like meter, and then Uranos, the ancient Greek god of the sky, which contained the position of over 1,500 stars. And what he did is, instead of using kind of naming them, he said it was probably more practical to kind of rank them in terms of importance or brightness within the constellation. So this is where we get the Alpha Centauris, or ones that have Greek letters. Is in his system, he ranked stars based upon their brightness or importance with first a Greek letter. Now, some constellations had more stars than the Greek alphabet, which is, I believe, is 24. So they went through Alpha all the way down to Omega. Then they started using Roman letters, and these were lowercase. So that's why some of them you might find, let's see, let's find a large constellation. Let's go to Draco, I think. Draco's got a lot of stars here. Yeah, so right here, a Defar, that's an F Draconis. So it's that star in terms of brightness. We went through all Greek letters, and then we started using lowercase letters there. We got up to F. It's a Chi Draconis, Delta. So in that case, he did that for all the constellations he's able to see in the northern hemisphere. And it became one ranking system. Now, some stars, they're just kind of known by their Bayer system name, largely because they didn't have a proper name, or in the case like Alpha Centauri, its name is Rigel Centaurus, which means foot of the centaur, and that often can be confused with Rigel, which is a bright star that's the foot of Orion. So Alpha Centauri basically became more a common name, even though it did have a Arabic proper name. And that's listed here. If I have my configuration window information, catalog numbers, that's going to be the first one here. So it's going to be a Greek letter or Roman letter, and the short abbreviation for the name. Now, a little bit later in the 1700s, by this time the telescope has been invented, more and more stars are discovered. It's just not practical to kind of give everybody a letter based on the constellation. There's also kind of issues of constellations being revised, and at the time, your different European powers really didn't agree, particularly France and England, on kind of the names of different constellations. So that was kind of an issue. But in 1725, English astronomer John Flamsteed compiled a new catalog of 2,935 stars. So here, stars fainter than the unaided human eye could see were now visible. So he tried to start to organize these stars by a right extension. So right extension again is, think of it as the longitude of stars, so going around east to west, and we base our system off Greenwich Mean Time, which runs through England. It's observatory there at Greenwich, so that's 0 point, and then as you go around 15 degrees across the sky is a shift of an hour. If you go around that, that's 24 hours, and conversely, that's also 24 hours in right extension motion. So with that, stars were kind of basically given a number based on their position. So if you see something 27 Hercules here, that is its ranking in terms of the Flamsteed system. Now, of course, you might expect over a long enough time, more stars get discovered, and it makes this system very difficult because now you have to reorder them. But so instead of doing that, since then we've had other catalogs that get rid of the concept of constellations themselves and then just base the measurements, the name of the star either in order of that survey or in some bright star catalogs, they name it based upon kind of starting in right extension. And that would be kind of, you see anything corresponding to Hipparchus, which is HIP number. Let's see, which I do think this star has. Let's see. Oops. Right here. HIP. So Rastaban, even though it's Beta Draconis, it's 23 Draconis in the Flamsteed system, and then in kind of Hipparchus Bright Star catalog, that's the 85,670th star in order in terms of right extension around the celestial sphere. Okay. And some more information about that Hipparchus is they came about as more and more precision was needed. Eventually, in the 1990s, at the end, the European Space Agency sent up the Hipparchus satellite to make high precision measurements and such for the data sets that that group used to analyze those stars. But in any case, with that, let's say, what are the Bayer, Flamsteed, and Hipparchus designations of the star Alkaid, which makes up the handle of the Big Dipper? So I'm going to type that in. Alkaid. That should take it right here. So what you'll need to do is write down the Bayer system name. So this is Eta, I believe. Ursa Major. I'm sorry. Yeah, but it's part of the Big Dipper. Ursa Major. 85 is his Flamsteed number, and its Hipparchus number is 67,301. Okay, so that is question 11. All right, so not much more time left here. Let's see. Okay. So let's take another observation of the Big Dipper. Zoom out. Okay, see our horizon here. All right, so I need to go to June 1st, 2006. And check the atmospheric visualization. Okay, so at the horizon now I can move around if I wanted to. All right, so let's see. So now I can see the full rotation. So if I basically advance time, you can see the Big Dipper appears to rotate around Polaris, and you always have these 2 pointer stars always directed toward Polaris itself. So if you are navigating, you want to see some stars. If you're able to pick out the Big Dipper, this allows you to kind of find other fainter stars. So you want to find true north. What you do is you look at these 2 ones on the edge, look at their direction. Okay, so I do have a kind of a diagram kind of illustrating that here within the instructions. So let's pull this up here. I can stretch across here for the pointer stars. Okay, so it's about 34 degrees going from the further of the pointer stars to Polaris itself. And the proper names there are Dubhe, so Dubhe. Okay, and sorry, I click that out. Let's zoom in over here for the other star. So the 2 pointers are Dubhe and Mirak. Okay, so that is for the Big Dipper. So if you follow those 2 stars, it'll take you to the Little Dipper. And here, the Little Dipper contains Polaris in a kind of smaller version of the Big Dipper, with them having an arc of the handle and then kind of the box stars. So let's see. Click on Polaris, try to identify the stars of the Big Dipper, and then activate the asterism lines and labels. Aside from Polaris, what is the proper name of the star that appears to be the brightest? So let's activate our asterisms. Okay, they are there. Okay, we have an engagement ring of Polaris. These grouping of stars, with Polaris being kind of the center wedding gem there. So Polaris does have quite a bit of other names in other cultures. It is Alpha Ursa Minor. It's also, their system is 1 Ursa Minor, and it has a Hipparchus number of 11767. Oh, I'm sorry. That's for Polaris. Now, aside from Polaris, what's the proper name of the Big Dipper that has, so the other bright star? Okay, I'm sorry, that would be Kocheb, which would be Beta, or the second one in that ranking system. So Kochab. And as you can see, there are other Latin names for these other bright stars that make up the asterism itself. Okay, now the Big Dipper can also be find a few other constellations. So And again, this is actually illustrated in my notes for the ones that talks about stars and constellations. You can arc or follow along this handle. So you go all the way out to Alcade, and this leads all the way to the star Arcturus. So Arcturus, which is let me get rid of the asterisms here. Part of, let's see, Uutez is how it's pronounced. I believe it is a herdsman, what translates into ancient Greek. Put the art out there. Yep. Basically, almost like a shepherd in a sense. But you have an arcing here for the handle to Arcturus. And then if you follow through, it goes to the star Spica, which is the brightest star in the zodiac constellation of Virgo, or the Virgin. So that's kind of just kind of a short way you can use the Big Dipper to find these other bright stars on one direction of the handle, and then you're able to go to Polaris, and even if you go beyond Polaris, go across. On the other side is we have Cephas, the king, and you should also be able to see a kind of a W, which is Cassiopeia, which is the queen. Okay. So that takes us there. Okay, so we got Arcturus and Boötes. So I need to first, for the proper names of the stars that make up the W of Cassiopeia, and then the 5 stars that make up Arcturus. So let's zoom in on those two guys. All right. And again, their proper names are listed up at the top here. Hopefully this is clear for people watching this. Okay, so those are the 5 that are part of Cassiopeia. And now let's arc back over to our friend Arcturus. And I believe we need to find the kite shape there. So again, the kite is going to be probably this portion. So we have Arcturus is our Theba. Okay, let's see. So we got Theba, Nectar, Cygnus, and we also have Ru, Boötes, and that's it. So these 5 right here, plus Arcturus, make up the kite of Boötes. And I think that is it. So anything else beyond that? Actually, nope. Yep, sorry. So we have one more. So Arcturus and Boötes, then finding Spica, the constellation Virgo. Kind of showed that, but we had another asterism over there, which is the big diamond. Okay. So these 4 stars are the big diamond. Spica, Denebola, Cor Carioli, and Arcturus. Okay. All right. So you have your answers now for your 17 questions, but then under data discussion, please be sure they have the introduction, your summary of procedure and your conclusion. And this should summarize this lab, and I will hopefully we'll work on and have an introduction for the next lab as well pretty soon.